Hello everyone. Today we will be starting with Spring Boot core concept. Okay, so first we will learn about IOC. IOC stands for Inversion of Control. So it is basically a principle in software engineering which transfer control of objects or portion of program to a container or framework. We most often use it in the context of object oriented programming. In contrast with traditional programming in which our custom code makes call to library, IOC enable framework to take control of the flow of program and make call to our custom code. If we want to add our own behavior, we need to extend the class of framework or plugin. Okay, so this seems bit confusing what I have read so far, but I will explain you in a very simple way. Okay, suppose I have got this page. Okay, yeah. Okay, I've got a class student and a class teacher. Okay, somehow student class is using a teacher class. Okay, something like this. I've got a student class, I've got a teacher class. Student is using a teacher class. So what problems do you see? It is a hard coded stuff. Okay, and it is tightly coupled. Suppose I want to write a test, then I have to initialize this teacher class. Okay, and it is if any change happened to the teacher class, then that change has to be adjusted in the student class. So first thing is it is tightly coupled. Second thing is it is not easy to test. Okay, so we have got two problems with this way of writing code. But suppose we write code something like this. TS teacher, teacher. Okay. Okay, it is difficult for it to recognize. So I will select teacher instant. Okay. Now, what is the difference? Difference is now if we want to test a student class and some change happened to it, then we don't have to adjust my code here. Okay, first advantage. Second is it is loosely coupled. Okay, I can easily test it and I don't need to reinitialize or readjust anything in the teacher instance. There are two advantages. Okay, I will give you reason why I explain you this concept now. Okay, so what container does, this IOC container does, it take control of flow of a program. Suppose I am using object, so object, if I use object, then first I have to create an object, then I have to use it, and then I have to destroy that object. Normally that work is done by the garbage collector, but somehow I have to configure it like this. Okay, so that complete life cycle of object is managed by the container. So advantages, so what are the advantages of container, of this IOC container? First is it is decoupled. It is like um, it is like loosely coupled. Okay, second advantage is it encourages testing. Okay, it means testing is not very complicated with the loosely coupled component compared to the tightly coupled components. Okay, and automatically it leads to the modularity, and obviously we can switch it from one implementation to another implementation. We'll go into detail of these concepts. Okay, first I'm just discussing it and later I will go really into detail of these concepts. Okay, we can achieve inversion of control through various mechanisms such as the strategy design pattern, factory pattern, and dependency injection. Okay, so we will begin with dependency injection now. Okay, so what is a dependency injection? It is a pattern which implement IOC, inversion of control, where control being inverted is setting an object dependencies. Okay, connecting objects with another object, with other objects, or injecting object into another object is done by assembler rather than by the object themselves. Okay. However, when we would create an object dependency in traditional programming like this way, as I showed you the example, this way we create object in the traditional programming. But there are disadvantages. First is it is hard to test. It is tightly coupled. So if I make change to one component, then I have to make change adjustment in the other component. Okay, it will cost me time, and yeah, productivity will certainly go down if I have to deal with this kind of system. Okay, so in example above, we need to instantiate an implementation of item interface within the store class itself. So how dependency injection can help us? Okay, let's see it. Using dependency injection, we can rewrite the example without specifying implementation of item. Something like this. It is loosely coupled. If any change happen to item, I don't need to readjust that change. This is the first thing. It can be easily tested. Second thing, and automatically it will save my time and leads to better productivity. Okay, in the next section we will look at how we can provide implementation of item through metadata. Both IOC and DI are simple concept, but they have a deep implication in the way we structure our system. Okay, so dependency injection is basically an implementation of IOC containers. Okay, so they are well worth understanding fully. But there are different types of dependency injection that we can discuss. And here what I'm talking is everything is in the context of Spring Boot. Okay, so constructor based dependency injection. In case of constructor based dependency injection, the container will invoke constructor with argument each representing dependency. Suppose we have got configuration annotation, app config, bean, item 1, and here we have got another bean, and that is invoking a class new store item 1. So here we are passing a bean to this class. Okay, so this is basically a constructor of that class, and it is a parameterized constructor, and here we parameter is a bean item. Okay, so yeah, so let's begin with the setter based dependency injection. For setter based dependency injection, the container will call setter method of our class after invoking a non-argument constructor or no argument static factory method to instantiate a bean. Let's create this configuration using annotation. Okay, so here we have a setter based dependency injection. Okay, we can combine constructor based and setter based injection for the same bean. Spring documentation recommends using constructor based injection for mandatory dependencies and setter based for injection for optional dependencies. So most of the cases, if we have mandatory dependencies, then it is recommended to use constructor based injection, and it is yeah, and yeah, and in the normal software development, especially when we are developing a Spring Boot application, we define constructor based injection something like this. I'll show you. Wait a moment, please. Controller. Yeah, here you can't see anything. Means what we discussed that you cannot see. The reason is this annotation. At runtime, this annotation will create a constructor and inject two beans, and hence our purpose of injecting beans will be solved behind the scene. So this is one of the major advantage of Spring Boot, that most of the complex work is done behind the scene. So you as a developer only need to focus on core logic. But it's good to have deep understanding of framework you are working with, because in some cases you might need to know uh, complex and internals of Spring Boot. Okay, so yeah, here we are done with the setter based dependency injection. And now let's begin with field based dependency injection. So that's how we inject dependency in Spring Boot. Okay, so in case of especially in field based injection, okay, in case of field based dependency injection, we can inject dependencies by marking them with auto byte annotation while constructing the store object. If there is no constructor or setter method to inject the item bean, the container will use reflection to inject item into the store. It will use reflection. Reflection is one of the feature in Java, and it is indirectly used a lot in Spring Boot. Okay, I could create some tutorial on reflection also, but in this it's good to have knowledge of reflection. And if you don't know, then I could say that you could consider reading a book, Effective Java. Okay, so constructor will use reflection to inject item into the store. Okay, so I can try to see. Okay. Mhm. So here we have to deal with qualifiers. Qualifier is one of the most important feature in dependency injection, especially when we are dealing with the ambiguity. Okay, we are dealing with multiple similar kind of a bean, and we have to choose one among those similar beans. In that case, qualifier help us to solve that problem. Okay, so qualifier annotation in Spring Boot is used to resolve ambiguity. When you have multiple beans of same type and want to inject a specific one, it helps Spring determine which bean should be auto-wired when multiple candidates exist. Okay, so suppose we have got food service. And we have got class formatter. Okay, we are injecting it, and just ignore it right now. Okay, and we have got a component foo formatter, it is implementing formatter. We've got another component bar formatter, it is implementing formatter. Okay, so we are injecting private formatter and reference variable. In this case, how we can distinguish between foo formatter and bar formatter? Then this is the factor. This is the annotation which can help us to distinguish between foo formatter and bar formatter. Okay, so yeah, by including this annotation together with the name of a specific implementation we want to use, in this case foo, we can avoid ambiguity when Spring find multiple beans of the same time. We will also do a very nice example on this thing. Okay, but let's focus on theory and concept. So in future this concept will help us to implement solution to improve our understanding about qualifiers. Okay, okay, so here we got a bit more detail about Spring IOC container. Earlier we discussed about IOC container. Okay, here we get into little bit more detail about Spring IOC container. So IOC container is common characteristics of framework that implement IOC. Spring framework interface application context represent IOC container. Okay, Spring container is responsible for instantiating, configuring, assembling object and known as bean. So every object inside the container, inside the Spring container, is known as an object. and a Spring container is responsible for the management of its life cycle. Okay, so Spring provides several implementation of application context interface. For example, annotation config, application context, class path, XML, application context file system for standalone application, and web application context for web application. So this is more on the Spring side. Okay, we are not discussing here about Spring Boot. Okay, but Spring Boot is an extension of Spring, so that's why it's important to have knowledge about these concepts also. In order to assemble beans, container uses configuration metadata, which can be in the form of XML or annotation. Okay, so yes, so this is what we have to discuss about the Spring IOC container. Next page is about bean lifecycle, but let's go a little bit more about IOC container and application context, because application, if you understand application context, then you understand about the Spring IOC container, and then you could proceed with the next concept. Okay, so here I created a small application which is from the previous example. So let's see. Here we have a main class, Spring application dot run demo application. So what is inside it? Let's see. Okay, we have got a Spring application class. Do we have application context? Let's see. Application context. We have got application context factory. Configurable application context. So I see like there are 104 application context. Okay, configurable application context. I see only configurable create application context. Okay, so here we are getting instance of configurable application context. So configurable application context is an interface that extends from application context. Okay, so it is like a container, and I could say it is extending from container. It is an extension of container which we are talking. So yeah, so we have got application context in our code. Without it, we cannot think of containers. So this is managing our beans. Okay, so here we are dealing with application context in this demo project also, but it's a bit different, okay, than what is mentioned here. But this is pure Spring side, and what we have is a Spring Boot project. So Spring Boot also needs a Spring application context. So that's what we want. And yeah, if we want to go a little bit more detail of it, let's go into application context. We have got bean factory. Okay, so yeah, that concept we will discuss later. Okay, so as of now it is quite clear that we need application context in every Spring project, and every Spring Boot project is an extension of a Spring project. So in every Spring Boot project we will certainly find application context directly or indirectly, means maybe some kind of implementation of application context, or might be we find directly application context. So anyway, we are dealing with containers, so we have to deal with container in every Spring project, and container stands for IOC container in this context. Okay, so let's begin with the bean life cycle. What is bean life cycle? What is a bean? First of all, bean is an object inside the container, and container is responsible for complete life cycle of that bean. Okay, so life cycle of a bean in Spring framework refer to the series of steps and methods that a bean goes through from its instantiation to its eventual destruction. The life cycle of a bean is managed by Spring container brackets bean factory. Okay, so what is a bean factory? We will find out. Which is responsible for creating, configuring, and destroying bean according to the defined bean scope, singleton, prototype. These are bean scopes. That is another concept. We will deal with it in just few minutes. It follows the series of steps as described in the below image. Okay, So this image show like instantiation. Okay, then populate properties. Properties get populated. Then bean name aware. Then bean factory aware. Pre-initialization bean post processors. Initializing bean after property set. Then init method is invoked. Then post initialization bean post process, and then bean is ready to use. So much process, and see, so many things happen behind the scene. Okay, we do when we define a bean annotation bean, we or maybe some kind of components, like for example annotation component service repository. In that case, we just define annotate that class, or maybe class mostly. So we don't have to worry about these steps, because they are happening at the behind. They are happening behind the scene. And after bean is ready to use, then container will shut down, dispose the bean, and custom destroy method will be invoked. Okay, so let's find out, like, do we really have something like this? Okay, let's go to the bean factory. Here we have got a bean factory. Okay, okay, so it's type all classes. Okay, so bean factory is a basically interface, and application context extends from bean factory, so it's like a subclass of bean factory. That's what I understand so far. And then we have to find the life cycle, like there are different events happening. So here we can get bean definition. We can also get complete definition of bean, like how many beans do we have. Okay, okay, see, you see this thing, set id, set parent environment, and then add bean factory post processor. Have a look at it. Set properties, set bean aware factory, bean post processors, bean post processors. So this complete life cycle, listener, then remove listener. Okay, refresh, register shutdown hook. When shutdown hook is registered, then bean will be closed. After that, close method will be invoked. So yeah, this life cycle really helpful when we are dealing with like complex Spring applications. So this life cycle we are able to see in the application context, like configurable application context. But in other cases, it is possible that other subclass of application context could also be implementing something very similar. Okay, if we go a little bit here, add bean factory, it is abstract application context. Okay, life cycle. What is life cycle here? Okay, start, stop. This is just separation. It has nothing directly to do with the bean life cycle. Okay, so now we understand that we have to instantiate, then we have to populate, then we have to set bean name, factory name, bean post processor, and then we have to initialize bean after properties are set. Okay, then custom, we call custom init method, and after that bean post initialization, bean post processor will be invoked, and then bean is ready for use, and after that container shutdown is hooked, and then disposal bean destroy method will be called, and then custom destroy method will be invoked. Okay, so that's how bean lifecycle works. Okay, and this complete management is done by bean factory. Not by bean factory, sorry, by Spring container, that is application context. It is written annotated, it is written in bracket that bean factory, but bean factory is a superclass of application context, so indirectly it is managing complete beans. It is responsible for bean life cycle, so that is done by bean factory. Okay, and this scope we'll discuss in a very short time. Okay, so understanding spring bean life cycle. Okay, so I explain you this picture because here is the theoretical part, and okay, let's discuss some annotations. Spring provide multiple way to define custom initialization method. Using post construct and pre-destroy annotation, you can mark method to be called after bean initialization and before bean destruction. So this method is invoked after bean initialization, and this annotation will be invoked, like method annotated with this bean will be invoked before destruction. Okay, implementing interfaces by implementing the initialization bean. So here we are implementing some interfaces by implementing the initialization bean and disposable bean interface. By implementing the initialization bean and disposable bean interface, you can provide after set property and destroy method. Okay. So I yeah, it's very from definition it is very clear that this disposable bean will have destroy method, and if any interface implementing initializing bean, then this method will be invoked. Okay, which the container will call at appropriate life cycle stages. Okay, so now we look at this diagram, and this diagram can give us little bit better understanding. Okay, so first bean is created, then dependencies are injected, then bean is initialized, bean is ready for use, bean is used by the app, then finally it is destroyed. It is very simple and clear, so it's very easy to understand. First bean is created, then dependencies are injected, and initialization is done, and once bean is ready to use, bean is used by the application, and after usage bean is destroyed. Okay, so when a spring container is closed, it triggers the destruction phase of bean life cycle. During this phase, the container call any custom destroy method defined for the bean. These methods are used to release resources and perform any cleanup necessary before bean is removed. Okay, what would happen if bean is not destroyed? What could happen? It is using memory, and something is using memory which is not useful to us. It could lead to memory leaks. Okay, so it is important to note that while initialization method are called for bean of all scope, destruction method are typically only called for singleton scope bean. Okay, this is very important to understand because prototype scope bean are not managed all way through destruction by container, and it is responsibility of application to handle their destruction. Okay, so singleton scope bean means one in single instance of a bean per application context. So normally spring bean scope is singleton by default. Okay, and there are some certain kind of bean scope, and this destruction method is called for singleton scope bean. Okay, it is not called for prototype scope bean, and we will know the reason why. Okay, very soon we'll get to know the reason. Okay, yeah. So let's deal with component scanning. It is one of the most important feature in Spring and Spring Boot application. What is component scanning? Why do we need him? And how we can optimize component scanning. Okay, so when working with Spring, we can annotate our class in order to make them into Spring Bean. Furthermore, we can tell Spring where to search for these annotated class. Okay, as not all of them must become bean in this particular run. If Of course, there are some default for component scanning, but we can also customize packages for search. First, let's look at the following: component scan in Spring application, component scan in Spring Boot application. Using component scan in Spring application. With Spring, we use component scan annotation along with configuration annotation to specify the package that we want to be scanned. Okay. So here we did not specify any package. It means this is scanning the current package. Okay. So here we have got configuration annotation. Then we have component annotation. Component scan is annotation, and I think it must be used in conjunction with each other. And here we have got a bean here, and then in the main method, this is like Spring annotation work. Okay, this is how Spring annotation code looks like. So here we have got application context, and it is loading this class, and then it is loading all bean definitions, and here we can see how many beans do we have. Okay, note that application class is also a bean, and as it is annotated with configuration, which is a component. Okay, so it is annotated with configuration, which is a component. So this is, what is this? I don't understand. Let's find out. Okay, however, we are dealing with Spring Boot, but it is very similar to Spring, like it is an extension of a Spring framework. So most of the notation it use. Okay, so here we have got a Spring Boot application. So what we have inside a Spring Boot application? Component scan. See, I'm lucky to have a component scan automatically configured. So what is component scan? It is, but it was written that configuration. Okay. Enable auto configuration. It is no. Spring Boot configuration. Yeah, see, we have got configuration annotation. And is it? Yes, it is an annotation. Yes, it is an annotation. It is a component class. So if you see uh, any class annotated with configuration, then you must understand that it is component behind the scene, and we will get to know what is component annotated class. Okay, component annotated class is basically a bean in a Spring container. Okay, we should also note that main class and configuration class are not necessarily the same. If they are different, doesn't matter where we put the main application class. Only location of configuration class matters, as component scan start from its package by default. Using component scan in Spring Boot, the trick with Spring Boot is that many things happen implicitly. Okay, so here we have seen like lot of things are happening implicitly. Okay, so we use Spring Boot Spring Boot application annotation, but it is a combination of three annotations: configuration, enable auto configuration, and component scan. Let's see, does it really have? Okay, Spring Boot application. Okay, enable auto configuration. Yes, it has. Then component scan. Component scan. Yes, it has. And then what? Configuration annotation. Configuration annotation we have also seen it is part of Spring Boot configuration, and here we have configuration annotation. So it is an alias. This is an alias for Spring Boot configuration. Okay. We will also discuss a bit about creating annotation and how to use them. Okay. So if one doesn't understand, then I will explain you everything. This is an alias of this. And this is an alias of component. Yeah, so a lot of things are happening automatically in Spring Boot because it is developed in this way. Okay, so let's create a similar structure in com.techwala.com scan or Spring Boot app. This time the main application will be, okay, so here we have got an application, a Spring Boot application. This is a name of class, application context, this is the name of a bean, then this is a class, and then we run check bean process. Okay, presence. Is cat in application context true? Cat, dog, rose, example bean, everything is present. Okay, the reason we are checking the bean for existence in this example as opposed to printing is that output would be too large. This this is because of implicit enable auto configuration annotation, which make Spring Boot create many beans automatically, relying on dependencies in pom.xml. Annotation component scan with specific package in Spring application. We can do this different way. First, we can change base package. Okay, so here we are specifying a specific package. Okay, and we are doing it in conjunction with configuration. So suppose we are doing directly in Spring Boot application, then maybe we are not doing it in conjunction with this. Okay. Okay, so there are some stereotypes annotations. So Spring has provided a few specialized stereotype annotation. For example, controller, service, repository, they all provide the same function as component. Let's see it. Okay, we have got controller, REST controller, we have got service. Okay, service do we have? Okay, so first we see controller. We go inside controller, it is an alias for controller. Okay, let's go inside controller, it is an alias of component. So indirectly my REST controller is a component. Okay, so I do one thing, I delete this because okay, now we have I will show you another thing. Okay, here we have component in Spring Boot, component annotation. Okay, we have got service annotation, we have got repository, and we have got REST controller annotation. Then we have another okay, so that's how it is working. So this is how, this is the concept. Like indirectly they all are component, but they present themselves as service, repository, REST controller. The REST controller is alias of controller, controller is an alias of component. We can also create our custom annotation. Okay, our custom annotation. CUS. Okay, spelling is wrong. Okay, custom annotation, and then we can also create it as an alias for this. Okay, and that's how we can create alias for components. Okay, so I think it is cleared very well, and in case you have some doubt, you can write me in a comment. Okay, they all act the same because they are composed of annotation with component as meta annotation. For each of them, they are component alias with specialized uses and meaning outside Spring auto detection or dependency injection. We could theoretically use annotation component exclusively for our bean auto detection need if we wanted to. On the flip side, like on the other side, we could also compose our specialized annotation that use component. However, other areas of Spring look specifically for Spring specialized annotation to provide additional automation benefits. So we should probably stick with using established specialization most of the time. Let's assume we have an example of each of these cases in our Spring Boot project. Okay, this is a beautiful example to understand all possible stereotype annotations: controller, service, repository component. This is a custom component, and then this is custom annotation. And here we created an example, and then this is a key test. Here we are extending with the Spring and extension. Okay, so we write test that proof each one is auto detected by Spring and added to application context. Controller example, and here we'll get answer true. So when we run this test, we will certainly see that test is succeeding. Okay, provided we have configured it really well. Okay, so now we will discuss Spring Bean scope. So Bean scope is one of the most important part in Spring because it enable developer to define the scope of a bean, like what is the purpose of defining this specific bean. Okay, so there are 6 kind of scopes. First, like singleton, which is a default, then prototype. Okay, scope, a single bean definition to any number of object instances. For every object there is a single bean definition. Okay, then there is a request. It is valid for one life cycle, like request and response. Okay, each request has its own instance of bean created of back to a single definition. Only valid if context of, it is valid in the context of web aware Spring application context. These 4 are valid in the context of web aware Spring 4 context. Session, as long as life cycle of HTTP session is valid, this scope is valid. Okay, I have to charge my computer. Oh. So application. Okay, so here we have got session and application single bean definition to the life cycle of servlet context. Okay, it is also kind of a singleton uh, scope in the context of servlet is context. Okay, not in the context of application context. So singleton is a single object instance for every application context. It is a single object instance for every servlet context. This is the main reason why I created a small lecture on servlet for Spring Boot, so I could explain you a bit more about servlets. Okay, and here we have got WebSocket scope, a single bean definition to the life cycle of WebSocket. We will explain this. I will explain you these things really deep. So let's come here. Okay, So when you create a bean definition, you create a recipe of creating an actual instance of a class defined by that bean definition. The idea bean definition is recipe is important because it means that as with a class, you can create many object instance from a single recipe. From one recipe, you can create many objects. Okay. You can control not only various dependencies configuration value that are to be plugged into object that is created from particular bean definition, but also control scope of object created from particular bean definition. The approach is powerful and flexible because you can choose the scope of the object you create through configuration instead of having to bake in the scope. Bean can be defined to be deployed in one of the scope. Spring Framework supports 6 scopes, 4 of which are available if you use WebAware. So if you use WebAware context, then 4 of which are available. Otherwise, 2 are available. So overall, there are 6 available to you. 6 scopes available to you. Okay, so as I mentioned, I will go really deep about bean scope. However, I'll go deep enough to explain you, not deep enough to really deep. Okay. So singleton scope is only one shared instance of a singleton bean is managed, and all requests for bean with ID or ID matches bean result in that one specific bean instance being written by Spring container. So for every Spring container, for every application context, there is only single instance. So this is the meaning of singleton scope. Okay. Here we can define it like this, or we can define it through annotation. Here we discuss about prototype. Prototype is certainly non-singleton prototype scope of bean deployment. In the creation of new bean instance, every time a request for that specific bean is made, that is bean is injected into another bean or request through get bean. As a rule, you should use prototype scope for all. Okay, so there's the rule. Like if you are using bean for stateful bean, then you must use prototype scope. If you are using bean scope for stateless bean, then you must use singleton. Okay, this is one simple definition. Okay, and in contrast to other scopes, Spring does not manage complete life cycle of prototype bean. Container instantiate, configure, otherwise assemble prototype object, hand it to client with no further record of that prototype. So for every request, there is one instance of prototype bean is created. So life cycle is quite shorter than singleton most of the times, and thus although initialization lifecycle callback are called on all objects regardless of scope, in case of prototype configure destruction lifecycle are not called. Yeah, that's why I mentioned that its lifecycle is quite shorter than singleton being lifecycle. Client code must clean up prototype scope object and release expensive resources that prototype hold. To get Spring container to release resources held by prototype scope, try using a custom bean processor which hold reference to bean that need to be cleaned up. All lifecycle management paths at point must be handled by client. Okay. So here it is getting really deep. So here we discuss about request scope. Spring container create new instance of login action by using login action bean for every HTTP request. This is scope at HTTP request level. You can change the internal state of instance that is treated as much as you want. Created from same login action bean definition to not see these changes in state. They are particular to individual request. So for one request, there is a request scope. Okay, session, as long as session maintained, like request response lifecycle is maintained, as long as session bean is maintained. Okay, Spring container create a new instance of app preference using this app preference bean definition once for entire web application. Okay, so one instance per application or one instance per servlet context. Okay, this is somewhat similar to Spring singleton bean but differ in two important ways. It is singleton per servlet context. As I mentioned, that application scope is singleton per servlet context, not per application context. Okay, it is actually exposed and visible as a servlet context attribute. So life cycle is bit longer than session. Okay, and here we have a last scope, that is WebSocket scope. WebSocket is associated with with the life cycle of WebSocket session and applies a stomp over WebSocket application. Okay, so yeah, its life cycle is for WebSocket sessions. Okay, we might go into detail when we deal with WebSockets. Okay, but as of now, it is not too important for from this context. Okay, we are mainly focused on these five. Okay, and we will certainly understand them bit more deeper when we do some practical examples. Okay, so then we could I could explain you these things much better. Okay, so here we are done with the scopes. Okay. So here we're done with the scope, and then I have to deal with the Spring context. Okay, so Spring context is a core component of Spring framework, provide a way to access configured objects like registry, it inherit from Spring Boot, and add support for internationalization, event propagation, okay, and resource loading, transparent creation of context. We will certainly see events also, okay, because it's very important to know about events, and then we can trigger different activities in a Spring Boot while applying at different stages of events. So those events are known as quiet application events, and we will certainly see it just in a few small moment. Okay, so here we have got some key features of Spring application context, like dependency injection. We discussed it. Event handling, that we will see it. Internationalization, like how our application support internationalization. We've got message resolution. Suppose we got message in French, German, Italian, how it can handle message in different languages. Resource loading, provide method for accessing application component, loading file resource in generic fashion. Java based configuration use bean annotated method with configuration class. This method is preferably for its simplicity and type safety. Okay, it uses bean annotated method within a configuration class. This method is preferably preferred to simplicity and type safety. Okay. Okay, this is the one way to to configure beans. Okay, like yeah, it's a part of a Spring context actually. Mm. So you can see that it is parameterized constructor, and it is default constructor, and this bean is getting instantiated here. So let's have a look at event propagation. So when we go deep inside this Spring Boot application, we'll get to know many things about events also sometimes. Hmm. So let's go inside. This is configuration. Okay, enable auto configuration. No, not here, sorry. This was the annotation actually. Hmm. Okay, so we go through application context. Events. So first we get into see application event publisher. Perhaps here we could find application event. Yes. See, we have got certain events like application failed event, application ready event, started event, starting event, change event. So all these are the stages of events. Okay. So for example, our application is ready, then we can trigger this event. Or when application started, a starting change event. So certain event could be triggered at this stage. Okay. Yeah. So yeah, event propagation is quite done, and we can understand these things better when we do some practical examples. Okay. And yeah, resource leading and these are like interrelated. Event was a bit different, and dependency injection is something we will always use in Spring Boot Spring application development, and not only Spring application development but also in normal software engineering practices. In some other different framework it is also used quite heavily. Okay. Because software engineer want to improve practices and write better softwares, so good practices are really important. Okay. Okay, so in case you want to go into documentation, you can have a look at this docs.spring.io, and in case you want to try out something as a project, mini project, then I would suggest take this project. Okay, so we discussed this a bit now. Okay, so we have got this tool out. Okay, so we have got a student, student, and then teacher. No, no, yeah, teacher. So what student take from teacher? It is a course. Okay. Okay, so student take a course and teacher deliver a course. Okay, so we create application in which we have components, three components: student, teacher, and course. And we have got admin. Admin is like administrator of school. Okay, who introduced some courses and then he assigned those courses to teacher, and then teacher and admin decide which student should get into the course, and then they take classes. So suppose we are living in some city and there are certain demand of some course, like for example you are looking for some DevOps engineer. So to create DevOps engineer, one must take some students, and you cannot take any student. You take students who have some foundation, who know scripting, Bash scripting quite well. So admin decide who will be the teacher, and he will also make decision who will be the student. That decision will not be done made only by admin, but that student could also be contributed by teacher. No, not like this. I would say like this. Okay. I couldn't find that decision maker like. Ah, yeah. This is something which I needed. Okay. Mm-hmm. Okay. Decide. and then no, no, not like this. Okay, this is not so nice, but yeah, it is enough to understand. Like, okay, so admin and teacher will decide who will be the student. Then a student will get entry in the course, and then a student will take the course. Teacher will deliver the course, and yeah, this is basic diagram. Okay, so this is basic architectural diagram of like student workflow diagram, like student, teacher, and course. And yeah, so this is one basic, quick, and dirty diagram of how we go proceed with our first mini project. Okay, and once we are done with this mini project, then we will proceed with the yeah, then we proceed with the next tutorials, module 3, building REST APIs. But yeah, next this doing this will give us very good idea about many different concepts today we studied. So yeah, thank you very much for watching this video, and in case you like this video, then please subscribe my channel, and I wish you a very nice day.